Hello everyone, this is Satyajit Pattnaik and welcome back to my YouTube channel. Today's topic is on understanding deep learning. So we shall be understanding the basics of deep learning, what is neuron, what are the various neural network concepts in this particular video. And henceforth, going forward, we have a lot of topics to cover in my future videos as well. Now, before understanding about deep learning, let's try to understand the basics of machine learning at least. Basics as in what exactly is machine learning, what is deep learning, just the basic difference between them. I hope if you are already in this video, you might have already been knowing about these basic concepts, but let me try to refresh your memories. Now, machine learning is a subset of artificial intelligence. Using machine learning, we achieve AI. Accordingly, we also achieve AI via various other areas of researches as well. So there are other areas of researches like NLP, robotics, computer vision, machine learning, via which we achieve AI. So machine learning is just one part of it. And further, if you deep dive under machine learning, deep learning is also another subset of machine learning. It's studied under the machine learning concepts. Right now, deep learning has to be used only when you have enough data and only when your classical machine learning models are failing, without which you shouldn't you shouldn't necessarily start your proof of concepts by a deep learning technique, because building a deep learning technique is time consuming and its memory it also impacts the memory and the CPU utilization as well, right? So going forward in this particular playlist, we'll try to have an understanding on each and every further aspects, further areas of study like ANN, CNN, RNN, and different other topics as well. So let's get quickly started. Now, Geoffrey Hinton is called as the godfather of deep learning, and deep learning is the concept where it is said that it mimics the human brain. Now, human brain consists of neurons, right? Similarly, when it comes to neural networks, we have also neurons. So, a single neural network is basically called as a perceptron. And accordingly, when you keep increasing the number of neurons, so there are different other neural networks also, which we will be studying. So let's try to understand the basic difference between machine learning and deep learning using a small example, using a small diagram. As you can see the top image, it says that you have an input as in if you are dealing with a customer churn prediction model or a customer churn prediction use case, you have the details of the customers, right? Be it demographic details or be it the bank operations. Sorry, not the bank operations. It's a telecom database. So telecom use case. So anything related to the customer, maybe customer ID, customer name, gender, geography, how old is the customer in the system, what are the different contract types. That's going to be your input. Now, when you pass the input, we have already been knowing that in machine learning, there are different ways, different steps to follow, right? First, we have to do some kind of a feature scaling part. Then we have to do some kind of a feature selection part, then feature extraction, then some hyperparameter optimization, and then we build our classification model and then build our output. So EDA plays a vital role in machine learning, and the most important thing is feature selection and feature extraction. These are the two pain areas where normally the researchers or the machine learning developers fail. Like they had some issues earlier as well. Okay, so that's the most critical area to I would say critical area to focus on. Okay, but when it comes to deep learning, feature extraction, feature selection, and your classification entirely is taken care by the hidden layer itself. So when you call your hidden layer, when you call your input layer and hidden layer, there only you have to do some kind of configurations. There are some parameters which you need to know, but most of the tasks is done by the neural networks itself. So you can see the traditional machine learning uses handcrafted features, which is tedious and costly to develop. Okay. Deep learning learns hierarchical representation from the data itself and scales with more data. So that's the reason it is also told that deep learning has to be studied or has to be implemented when you have enough data, and only when your classical machine learning is failing. But I will also give you an example. For an example, you are getting 86% accuracy in machine learning model, and 88% accuracy in deep learning model. Whereas your machine learning model is taking 15 minutes to run the model, and your deep learning is taking almost 12 hours to run the model. So again, that's a call by a data scientist or some kind of machine learning engineers to have a decision making process. Because if you are compromising on the accuracy, you will have a better training time. But you don't if you don't want to compromise the accuracy, you will have a higher training time. So that's a decision making which actually a data scientist has to do. Okay, so we cannot advise that which has to be used. It all depends upon the use case. Maybe when I'm talking about medical use cases, each and every accuracy matters, right? Each and every percentage of accuracy matters. So in those kind of areas, healthcare domain or medical domain, where we can't get rid of this accuracy plays a vital role. We don't care about the training time. So in those kind of use cases, those kind of areas, we can stick to deep learning techniques. But let's say our use cases are not that critical and we want faster results, we can go for machine learning use cases as well. So I hope you had a basic understanding on these concepts. Let me try to draw a small diagram so that you understand the basics of it. However, this particular diagram we will also be doing as and when required. So let's try to talk about this particular churn prediction use case. Let's say I have customer ID, customer name, I have gender, I have geography. I'll mark it as G1, gender. Okay, and let's say I have contract type, let's say I have internet, or let's say I have bandwidth, and let's say I have something else, x1, x2, something else. Okay, and I have a column called as churn. That means it is yes or no. So how it happens is, let's say I already know customer ID is a randomly generated number and customer name doesn't play a vital role in the model building part, right? So let's say I have 1, 2, 3, 4, 5, 6 inputs. So what it will be, you have to, your neural network will look like this: 5, 6. There are 6 inputs. This is your gender, this is your geography, this is your contract type, this is your bandwidth, this is your x1, and this is your x2. Just considering that all these are your numerical variables. Obviously, if it is categorical, you will have to do one hot encoding and all those things, but the concept remains same. This is going to be your input. And then let's say I'm building a two-layered neural network. And in each layer, I will define 8 neurons. 5, 6, 7. Let it be 7 neurons. 1, 2, 3, 4, 5, 6, 7. And let's say it's a binary classification, right? Because I need an output as y or n. So there will be just one output. Now, if I just draw this diagram, this is how it looks like. 1, 2, 3, 4, 5, 6, 7. Just imagine there will be each and every neurons will be connected to each other. Okay, like this. So that's the reason neural networks are basically called as a messy network as well. So just imagine all the points are connected. So each neuron is connected to each neuron here. Similarly, here also all the neurons are connected like this, like this, like this, like this. Okay, I'm not drawing everything. And from here, this is how the output looks like. Okay, something like this, or else I'll make it a bigger circle, something like this. This is my output. Okay, so here this is a two-layered neural network, and we call this particular area as, this is your input layer, this is your input layer, this is your hidden layer, and this is your output layer. Okay, so this is a two-layered neural network where my first layer is my input layer, next two layers are my hidden layers, and this is my output layer. In case we are dealing with a tertiary classification or a multi-class classification, let's say we have multiple classes, cats, dogs, horses, and let's say eagles. We want to classify these animals. So obviously in output there will be 4 neurons, right? It will be like this, and all your dots will be connected like this. And Probably, let's say you are inputting one image into this particular model, your output will be something like this: 0.8, 0.1, 0.05, 0.05, something like this. So you can tell that your first list value is having the maximum value. That means it could be a cat, something like this. So that's the only difference between the binary classification and a tertiary classification. Okay, not tertiary but multi-class classification. Okay. Now when it is a regression problem, obviously your output will be a single value, right? It will not be classes. If you are doing a stock prediction or some time series prediction or something like that, your output will be just one number, right? 6 or 15 or something like that. So this is basically about the basics of the neural networks. In our future classes, in our next videos, we also talk about the ANN intuition in the very next class. We'll learn what is a neuron as in a basic building block of a neural network. What are the various activation functions and how neural network works, how neural network learns, and gradient descent and stochastic gradient descent and backpropagation. So next video is going to be a little bit lengthy, so stay tuned. Thank you guys. Please like and subscribe the channel, and please share it among your friends as well. Thank you.